So now that we kind of understand the coordinate system a little bit and how it works in terms of the components and the coordinates of ordered pairs, we're going to use graphs to represent the relationship between two things. And in the last lesson, we talked about independent and dependent variables. So we're going to use the graph in its question. We're going to solve problems and make predictions. So a patient is hooked up to an IV bag, intravenous bag, which continually supplies medicine to her bloodstream. The amount of medication in the bag, measured in milliliters, is recorded over a 12-hour period. The information is displayed in the graph below. Okay, so if we look here, we have two axes, our vertical axis, okay, which is our amount of medicine in the IV bag, and that's measured in milliliters. So milliliters is our vertical axis, and then on our horizontal axis, we have the time in hours. And if you think about it, an IV bag drains into the patient. So when you start at time 0, this is your starting point, and you start at 1,000 milliliters. And then as time goes on, the volume of the bag goes down. Okay, after 2 hours, it goes down to 800. So that after 2 hours, it's down, the volume is 800. Okay, and it shows that obviously, if the bag just keeps draining, eventually it will go down to 0. Okay, at 10 hours, the bag is emptied. Okay, so we can use this graph to answer the questions over here. So A asks us how much medication was initially in the bag. Well, initially in the bag, the initial time is at time 0. So when we first start, we just have a brand new bag. We go to time 0, and then we follow it all the way up until we hit our line, and our line says 1,000. So the initial amount in the bag was 1,000 milliliters. Okay. Then B asks us, how long did it take to drain the IV bag? Well, if we look over at the graph, when the bag is completely drained, it will be at 0. So we just follow the line down until it goes to the very bottom at 0. So the bag is drained here, and then we look on our horizontal axis, and it says at 10. And this 10, remember, is time in hours, so we write 10 hours. Okay? So it took 10 hours for the IV bag to drain. C, how many milliliters of medication were being supplied to the patient every hour? Okay, so this is where some math comes in, okay? So we had 1,000 milliliters at the start at time 0, and then it took 10 hours for it to get down all the way to a volume of 0. So if it takes 10 hours for 1,000 milliliters to drain, then we can just say, well, 1,000 milliliters divided by 10 hours equals 100 milliliters per hour. Okay? The other way to look at it is you could just look and say, okay, well, we know that after 2 hours, it's gone down from 1,000 to 800. So you could say, well, it goes down by 200 milliliters in this period here. So that's 200 milliliters that it's reduced by, and that's over a period of 2 hours, which still gives us 100 milliliters per hour. So you can see you can either look at the graph as a whole and take the total number of hours divided by the amount that was initially in the bag, or you can just take a portion of it and you come up with the same answer, 100 milliliters per hour. And the next question is, how much medication was in the bag after 4 hours? So this is where we go to our hours is on the horizontal axis, so it says at 4 hours, we look at 4, and then we follow it up until we get to our line, and where it touches the line right here, now we just look over at how much volume there was at that time, and it says 600 milliliters. So at After 4 hours, there were 600 milliliters in the bag. Okay, E. At what time was there 400 milliliters of medication in the IV bag? Okay, so in this case, we're looking for where does the line have 400? So it's asking what time was there 400 milliliters of medication? So we look over here, 400 mils, and then we can follow it across to this point where it hits the line, and then we look down and it says, oh, okay, so at 6 hours, the amount of medication left in the bag is 400 milliliters. So the answer is 6 hours. Okay, in example 2, it says a local trucking company was having difficulties finding qualified drivers. As an incentive to attract new employees, they offered a signing bonus on top of the regular hourly wages. The amount of money a new employee can make in his or her first week is described by the following graph over here. The money earned before deductions is on the vertical axis, so this is your earnings in dollars. That's how much the person is making. And the number of hours worked by the new employee is on the horizontal. So this is how much the employee worked, and those are the hours. Okay? So the first question is, how much was the trucking company offering as a signing bonus? Well, how do we know this? Well, the first thing is, if there's a signing bonus, if there were no signing bonuses, the graph would start right here, because you would just get, let's say, for 10 hours you would get $100. But if you never worked anything, you would not be paid anything. So we know there was a signing bonus. So the signing bonus is the initial amount where it just starts, because you can see here this person has worked, the employee worked 0 hours, but they already started. They earned $500 right off the bat. So that is our answer. How much was the trucking company offering as a signing bonus? So it was $500 signing bonus. Okay. B, assuming that we're dealing with a 40-hour work week, what's the maximum amount of money a new employee could make in his or her first week? Okay, so we look at the graph here and it says, assuming we're dealing with a 40-hour work week, what's the maximum amount of money a new employee could make? So we look over here, 40 hours. We scroll all the way up to here. This is where it meets our line. And at that point, our vertical value is 1,300, because we're assuming that they can get their signing bonus and then work 40 hours, and that brings them up to, at 40 hours, they earn $1,300. Okay, C. What is the hourly wage for a new employee? Okay, so this is where it's a bit tricky. If you look at our axis down here, there's not like, it doesn't tell us 1 hour, it's in increments of 10. Okay, so what you have to do is look at two things. You have to look at how much does it go from one grid line to the next. Okay, so that's 10 hours. Okay, and then how much does it over that same period where the line is going up, so that it goes up over those 10 hours, how far does that line go up? Well, it started at 500 and it went up to 700. So that means that it increased by 200. So we had $200 divided by 10 hours equals $20 per hour. So our answer is the hourly wage for the employees for a new employee is $20 an hour. And we could see that, again, if we wanted to go from here to here, from 10 to 20, well, that's 10 hours between 10 and 20. And again, their wage would go from, their money earned would go from 700 up to 900. So again, over 10 hours, over the next 10 hours, they earn $200 again. And $200 divided by 10 hours gives us $20 an hour. Okay, D. If a new employee only worked 30 hours in his or her first week, how much would he or she earn? Okay, so it's their first week, so they do get the signing bonus. And we want to know what would they earn if they worked 30 hours. So we go over to 30 hours, and we go up until we hit the graph, and at 30 hours, the value is $1,100. So that employee could earn $1,100 in their first week if they worked 30 hours. And the next question is, if the employee earned $900 in his or her first week, how many hours did he or she work? So now, instead of looking at the horizontal axis, we're looking at the vertical axis, and we want to go up to, it said $900 in his or her first week. So at $900, we go over until we hit the line. It hits the line right there, and that equates to 20 hours. So the employee would have worked 20 hours if they earned $900 in their first week, according to this graph. Okay, in example 3, we have Omar is going to have some gravel delivered to his property. The company that supplies the gravel charges a trucking fee plus a cost per ton of the gravel. The following graph shows the relationship between the cost of the gravel and the number of tons of gravel ordered. So let's just take a look at it here. So we have the number of tons on the horizontal axis, and then we see on the vertical axis we have our cost in dollars. So we see right off the bat our graph starts, even if you don't get any tons of gravel delivered, there's some sort of charge because your cost is $20, okay, just to engage the company. Now we see the cost goes up as the number of tons ordered increases, okay? So our first question is, if Omar orders 2 tons of gravel, how much will it cost? Okay, so we go over to 2 tons. This is tons, so 2 tons. How much will it cost? We go up till we touch our line, and this is the point where it touches our line. So at 2 tons, it's equal to $80. It's going to cost Omar $80 for that. 2 tons of gravel. Okay, B. If Omar can afford to spend $140 on gravel, how much can be delivered to his property? So in this case, they're giving us our vertical variable, so $140. So we look over in this column, go up to 140, go across, okay, and that's where it touches the line. So then we go down, and that's telling us for 4 tons of gravel, it costs $140. Or if he pays $140, he can get 4 tons of gravel. Okay. How much is the trucking fee? Well, this is what we talked about at the beginning. There's a trucking fee right off the bat. Even if you don't get any gravel and you engage this company, there's a $20 flat fee. So if a graph starts above 0, then there's some sort of fee whenever you're dealing with cost, right? So in this case, the trucking fee is $20. Okay. What is the cost per ton of gravel? So again, this is where we look. Okay, if we look at our tons axis, it does go up by 1, so that's good. So the question is, how much does it go up by? So for 1 ton of gravel, the cost goes from 20 up to, well, see, and that's where it gets tricky because it doesn't go to an exact spot. We can't really tell if that's 54 or 50, or it's not exact. So the best practice is to look over at where the line goes exactly through a point, or where it seems to go exactly through a point. So here it's going through mid. We're going to have to guess. Up here, again, it's going through a midpoint. We're going to have to guess. But right here, it looks like it's right on, okay? So we've got our point here that we just found, and we have to measure the change, okay? So we have to find another point to reference it from. So probably the easiest point to reference it from would be right here, this point, which would be 0.20, okay? So if that's our reference point, 0.20, okay, and we're looking at this graph saying, okay, if he doesn't have any gravel, then it still costs him $20, okay? But if he goes up to 2 tons of gravel, okay, then his cost increases up to 80. But it wasn't from 0, it was from 20. He already had to pay the trucking fee, right? So if we look at that, the number of tons that we're increasing by is 2, and the number of dollars that we have to pay goes from 20 to 80. So that's a difference. 80 minus 20 is 60. Okay? So again, that's $60 and 2 tons. So if we said $60 divided by 2 tons, that gives us $30 per ton. Okay? And so our question was, what is the cost per ton of gravel? It's $30 per ton. Okay? Now, the key on this is just to remember, okay, it's because that trucking fee, it starts here. It goes, it takes 2 tons of gravel is going to cost an extra $60. If we did it again and say we went to 4 tons of gravel and use this point here, again, we would find the same difference. From here to here is 2 tons. And from here to here, again, from 140 to 80 is again, that's $60 increase in cost. So what you notice is that this line has the same steepness. So if you pick any 2 points, which are eventually the difference in cost to the difference in tons that you receive, it always works out to $30 per ton. Okay, last question. If Omar needs 7 tons of gravel, how much will it cost? Okay, so we go to our graph and we look, but we run into a problem. Our graph only goes up to 6 tons of gravel. Okay, but we can still figure out our answer because we know it's 6 tons of gravel, it's going to cost Omar $200. But we also know that each additional ton of gravel costs $30. So if 6 tons cost $200, then 7 tons is going to cost another 30. So 200 plus 30 gives us $230 for 7 tons. So the key in this lesson is just recognizing trucking fees are initial costs that shift the graph upwards. Just interpreting based on where points are on the graph for if you can spend $140 on gravel, how much can you can get 4 tons. Trucking fee is your initial cost. Cost per ton of gravel, that's probably the trickiest piece, is you need to find 2 points, okay, and find out the difference for the horizontal difference and for the vertical difference, and then divide the vertical by the horizontal, and it tells you the rate per one, in this case ton. Okay.